In the Solve It, you identified several pairs of angles that appear congruent. You already know the relationship between vertical angles. In this lesson, you will explore the relationships between the angles you learned about in Lesson 3.1, when they're formed by parallel lines and a transversal. Here's a take note postulate, the same side interior angles postulate, or postulate 3-1. If a transversal intersects two parallel lines, then same side interior angles are supplementary. So if L is parallel to M, we can refer to the diagram below, the measure of angle 4 plus the measure of angle 5 equals 180, and also the measure of angle 3 plus the measure of angle 6 equals 180. Problem 1, identifying supplementary angles. The measure of angle 3 is 55. Which angles are supplementary to angle 3? How do you know? Well, by definition, a straight angle measures 180. If the measure of angle A plus the measure of angle B equals 180, then A and B are supplementary. That's by our definition of supplementary angles. And 180 minus 55, our measure of angle 3, equals 125. So any angle x where the measure of angle x equals 125 is supplementary to our angle 3. Well, the measure of angle 4 equals 125 by the definition of a straight angle, or a linear pair, where angles 3 and 4 form a linear pair, or add up to 180 degrees, and are supplementary. The measure of angle 8 also equals 125 by the same side interior angles postulate. The measure of angle 6 equals the measure of angle 8 by the vertical angles theorem, so the measure of angle 6 is also 125, and the measure of angle 2 equals the measure of angle 4 by vertical angles, or the vertical angles theorem, so the measure of angle 2 equals 125. Each of these four angles, 4, 8, 6, and 2, are all supplementary to our angle 3. Your turn. A reasoning question. If you know the measure of one of the angles, can you always find the measures of all 8 angles when two parallel lines are cut by a transversal? Explain.